What's up guys, today I'm going to be solving the sixth question on the 2019 AP Calculus AB exam. The question states, functions f and g and h are twice differentiable. G of 2 equals h of 2, which equals 4. The line y equals 4 plus 2 over 3 times x minus 2 is tangent to g and h at x equals 2. The first question wants us to find h prime of 2. Okay, so as we know, this is calculus basics. As we know, the derivative is just the slope at a certain point in a function. So if they want us basically to find the slope of h of 2. So if you remember, this equation is tangent to g and h at 2, which means we just need the slope, which is this, 2 over 3. So the answer of this would be 2 over 3. And that's it. It's as simple as that. Now on to the next question. Question B. Let a of x equals 3x cubed h of x. Write an expression for a prime of x and find a prime of 2. This might seem like a hard question, but honestly, it's not. As you can see, this is a product, so we use the product rule. Of course, you should know the product rule by now. If you don't, then why are you watching this video? Go learn it. Okay, so you get 9x, well, you have a of x equal 9x squared times h of x plus 3x cubed times h prime of x. That's for the first question. Write the expression for a prime of x. Now, to find a prime of 2, you just need to plug in 2 in every x inside of here, which should be simple. And when you do, you're gonna get this. Which you can evaluate quickly if you already know the values, but in case you forgot, h of 2, we can get it from the original question, h of 2 equals 4, and h prime of 2 from the previous question, we got h prime of 2 equals to the slope of this equation, 2 over 3. So you're gonna get in the end 36 times 4 plus 24 times 2 over 3, which comes out to 160, which is the answer for this. Okay, now on to the next question. Don't mind my outfit change, it just happened, you know, sometimes things happen. Anyways, let's go on to the question. Part C states h of x equals x squared minus 4 over 1 minus f of x cubed. The limit of h of x as x approaches to can be evaluated using L'Hopital's rule. Use the limit to find f of 2 and f prime of 2. Okay, this seems pretty complex, and well, it is. It's kind of confusing if you don't know what you need to do, but I'm here to guide you through it. I know, I'm a savior, I'm joking. Okay, so firstly, the limit of h of x as x approaches to, well, what's the value of that? Since h of x is twice differentiable and continuous, the value of the limit is going to equal to the value of h of 2 on that specific point, which is 2, which is going to equal 4. I said which is so much. Anyways, and as we know, h of x equals this. So the limit as x approaches 2 of this x squared minus 4 over 1 minus f of x cubed is going to equal 4. Okay, so now how do we find f of 2 and f prime of 2? Well, f of x is twice differentiable and continuous. That's important to know. And here it says that x does not equal 2, or it can't equal 2. Okay, so when can h of x not equal 2? When it's an indeterminate. And okay, if we plug in 2, the value of the limit, we're gonna get 0 here. And here, okay, what gives us 0 here? What 1 minus what gives us 0? 1, because 1 cubed is gonna be 1 and 1 minus 1 is 0. So this will come out to an indeterminate. Okay, so now that this is an indeterminate, what do we do? Well, f of x equals 1, so the limit of f of x as x approaches 2 is gonna equal 1. And as we know, because f of x is continuous and twice differentiable, when you evaluate or when you plug in the value of the limit inside of here, it's gonna equal to the actual answer. So f of 2 is 1. So now we have f of 2. Amazing, I know. Okay, so what about f prime of 2? What are we gonna do here? Well, f of x is differentiable, so that means the limit of f prime of x as x approaches 2 exists. So now we can just use L'Hopital's rule on this, as it says here. We can use the L'Hopital's rule, and we can just solve for f prime of x. Okay. As you know, the L'Hopital's rule just says that you can differentiate the top part and the bottom part, or to use L'Hopital's rule. So if we differentiate the top part, we're gonna get 2x over, now this is a constant, so it's 0, and this is a constant, so it's 0. Okay, so what about this? F of x is a function. It's not any variable, or it's not like 2x or something. So you can't just use the power rule on it. You need to use the chain rule. So using the chain rule, we're gonna get negative 3 f prime of x times f of x. And all of this is gonna equal 4. Okay, now let's plug in the value of the limit, and we're gonna get 4 over, okay, so if you f of 2 is what? F of 2 is 1, as we just found out. And if this is 1, okay, 1 times negative 3 is just going to be negative 3. And this is going to be f of 2, f prime of 2, equal 4. And now we can easily isolate the f prime of 2. Firstly, you can multiply this on both sides, and this will cancel out, and you're gonna get 4 equals 4 times 3. It's gonna be negative 12. 4 times negative 3 times f prime of 2. Okay, now you can just divide negative 12 on both sides, and you're gonna get f prime of 2 equal 4 over negative 12, which is negative 1 over 3, and that is f prime of 2 for you. And this is the entire question done. Now let's move on to the next part. So now on to the next part, which states that g of x is less than or equal h of x for 1 less than x, which is less than 3. Let k be a function satisfying g of x less than or equal k of x, which is less than or equal h of x for 1 less than x, and you know the inequality. Is k continuous at x equals 2? And that's such a good question that I don't even know. I'm joking, of course I know, I wouldn't be making the video. Okay, so to solve this, it might seem complicated, but I mean, you can do this mentally, honestly. I can't even believe I'm explaining. I'm joking. Okay, so firstly, let's start by plugging in 2 into all of these functions. And, well, okay, so g of 2 equals 4, as we know from the original question. And same goes for h of 2, which equals 4. So we're going to have 4 less than or equal k of 2, which is less than or equal 4. Okay, so since k of 2 is squeezed between 4 and 4, well, there's only one possible value. And no, it's not 4.1, it's 4. Unless you want to say 4.0001, I mean, I'm joking. Okay, so now we know that k of 2 equals 4. Okay, so this doesn't prove that it's continuous. So how do we prove that it's continuous? Okay, we have this thing called a squeeze theorem, which is amazing. I'm joking. Okay, we actually do have a squeeze theorem. And we're going to use that now. So to use the squeeze theorem, we just take the limit. Well, the squeeze theorem, according to the squeeze theorem, this is like the 5th time. According to the squeeze theorem, the limit of, as x approaches 2, of both g of x and the limit of, as x approaches 2, of h of x, well, they both equal 4. Okay, so that means the limit of k of x, the limit of k of x as x approaches 2 is gonna also equal 4. And, well, that's k is continuous now. Well, I've proven it. I mean, it seems underwhelming, I know, but it's that simple. You know, sometimes in life, things might seem complicated, but you just need to think. Okay, yeah, but that's it. That's the end of the video. You have part A, B, C, D. I hope you enjoyed this video. I hope you found it informative. And tell us in the comments, do you want us to continue making videos or should we end the channel? I'm joking. Hope you enjoyed and we'll see you in the next one.